All right, so this is chapter 10, section 4. It's called Ellipses. We've got 3 learning objectives today: to write the equation of ellipse, to find the foci of an ellipse, and to graph an ellipse. Easy peasy. Once we have our little components together, all 3 of those are really manageable. I would like you guys to please note that a circle is a special form of an ellipse. Just like a square is a special form of a rectangle, circle is a special form of an ellipse. It's where all of our axes are the same length and it makes a circle. So circle and ellipse are very closely related. So one of the key concepts, and please only write down what I highlight. An ellipse is a set of all points P in a plane. So it's all the points P in a plane, such that the sum of the distances from P to 2 fixed points, so if P is right here, F1 and F2, so the sum of those 2 points is a constant value K. The focus of an ellipse, plural is foci, is one of the 2 fixed points. So, and I don't expect you to write any of that down. What I would like you to write down is these 2 pictures. So one where draw this picture of the horizontal ellipse, make sure you label all the items, and then right next to it draw the picture of the vertical ellipse. So let's talk this over. In a horizontal ellipse, your major axis is along the x-axis or parallel to the x-axis if you're not centered on 0, 0. It makes a nice little oval shape. You have a vertex here at a comma 0 and negative a comma 0. You've got a co-vertex where you cross, or at 0b and 0 negative b. The short axis is the minor axis, the long axis is the major. And then it's switched around for a vertical ellipse. Vertical ellipse is where your major axis is the long one, and it's along or parallel to the y-axis. All right, so let's look at equations here, and if I were taking notes on this, I would make a little table. So I would definitely write key concept, properties of ellipses with center 0, 0. Then I would make a little table, and I would put 3 columns. And this line is really thick. Get thinner. There we go. So the standard equation, and the way you can differentiate between an ellipse and a circle is by the denominators here. So that you still have an x squared, you still have a y squared, but instead of equaling a value, we're going to equal a number, and a and b are going to be 2 different values. So the standard equation is x squared over a squared plus y squared over b squared equals 1. And a is bigger than b, which is bigger than 0. That just is saying that since a is the big guy and he's underneath x, then x is our major axis. When a is the big guy and it's underneath y, then y is the major axis. So whoever has the bigger number gets to be the major axis. So the length of the major axis is 2a and the length of the minor axis is 2b. All right, so let's use these. What is the equation in standard form of an ellipse centered at the origin? So let's write that. Okay, so the first thing I do, if they're going to give me vertices, I'm going to graph them because I want to draw a picture. So I have a vertex at 0, 5, so 0 and 1, 5, and a co-vertex at 2, 0. So that means because of the way an ellipse is formed, it means that I have opposite vertices at my green dots, and I connect all these dots with a smooth curve, and I get a nice little ellipse shape. So from this picture, I know that my major axis is here, and my minor axis is here. So A is from the center to the top of my ellipse, and for us that is 5. And B is from the center to the right hand side of my ellipse, and for us that is 2. So because my major axis is on the y, A goes here and B goes here. And let's actually plug in the numbers for those. So the main thing to remember is that you take the value is 2, and you square it. When I was a young student forever days ago, it was difficult for me to remember to square, and then conversely, when I'm finding the a and b from the equation, pulling it out and taking the square root. We're going to simplify this down one more time. X squared over 4 plus y squared over 25 equals 1. All right, so let's write this little snippet of information down that I found in your textbook. If plus or minus a comma 0, 0 comma plus or minus b, and plus or minus c comma 0 are the vertices, the co-vertices, and the foci of an ellipse, then the foci squared is equal to a squared minus b squared. So this is your relationship between the major and minor axes and the foci. So this is our link. This is how we're going to find the focus given the axes, or how we're going to find the axes given the focus. All right, so let's do this problem together. What are the coordinates of the foci of an ellipse with the equation 36x squared plus 100y squared equals 3,600? And then graph the ellipse. All right, so the first thing we want to do is we want to set this problem up so that it is in standard form. And right now, because this definitely does not equal 1, it is not in standard form. So I'm going to do some dividing. To get this to be 1, I have to divide by 3,600. But you know, the rule of things are to keep it equal, everything has to get divided by 3,600. So I'm going to divide by 3,600 and then simplify. So 36x squared divided by 3,600. 36 goes into 36 once, leaving me with just the x squared. And 36 goes into 3,600 100 times. 100 over 3,600, well, 100 goes into 100 one time. And 100 goes into 3,600 36 times. And now it equals 1. Yay! So we still need to find the coordinate of the ellipse. I'm looking, x is my major axis. So this is going to be a squared and this is going to be b squared. Whatever one's bigger gets to be a. So then I'm going to take this equation here, c squared equals a squared minus b squared. And I'm going to plug. A squared is 100. B squared is 36. C squared is equal to 100 minus 36. I happen to know that is 64. Because I'm magic. So C is 8. And in fact, it is plus and minus 8. Now it says write the coordinates. Let's go take a look at our little chart to see when we have the x-axis is our major axis, then our foci is plus or minus c comma 0, and it's on the x-axis. So we're going to write foci plus or minus 8 comma 0. Now we get to graph it, yay! So let's do a little, as lovely a graph as we can make it. So I'm going to need, if a squared is 100, what is a? 10. If b squared is 36, then b has to be 6. I need those so I can mark my graph correctly. So I want to go on the x-axis, I want to go out 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In both directions. 5, 6, 10. And then on the y-axis, I definitely need to go 6. That's terrible. I blame technology. Four, 5, 6, 7. Okay, so I'm gonna put my decimal, my coordinate of my vertices out here at 10 and out here at -10. I'm going to put it up here at 6 and -6. And then we're going to draw a nice, smooth, elliptical shape. Hopefully your ellipse looks as amazing as mine. This is why if you have graph paper, please use it. Next time when I have a graph situation, I will put down the graph. So, anywho, and then It doesn't ask us to put the foci on there, but I'm going to do it anyway because we're extra credit kind of people. So the foci is at positive and negative 8. So that's right here. Just for a little extra credit. Right there, the foci. Do not write this problem down. I'm just demonstrating. A room with an elliptical ceiling, called an ellipsoid, since it is three-dimensional, forms a whispering gallery. Thanks to the reflective property of the ellipse, a whispered message at one focus can be heard clearly. So if you whisper it here, whisper, 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 and it goes to the other focus by someone standing across the room at the other focus. If the elliptical ceiling has a major axis of 120 feet and a minor axis of 72 feet, how far apart are the foci? Well, they tell us that the major axis has a length of 2a, and that is equal to 120. So a has to equal 60. The minor axis is 2b, he's equal to 72. So that means b has to equal 36. So then using the C equation, the foci equation, c squared equals a squared minus b squared. So you got 60 squared minus 36 squared, and then you take the square root. You'll find that it's 48. The foci are half of that because, remember, your origin's in the middle. So it is 2c is equal to 96 feet. So 48 is half of that distance, and you need 2 of them to get the total distance. So, now, the question is, this is what I want you to write. How far apart are the foci of an ellipse with a major axis of 26 feet and a minor axis of 10 feet? So we want to find A, and we want to find B. So A is 13 feet, and B is 5 feet. The foci, distance of a one foci is a squared minus b squared. And 169 minus 25 is 144. So C has to equal 12. So remember, 12 is this distance. So if I'm going foci to foci, I need to add in another 12. So 2c equals 24. And then that would be C. So the distance between the two foci is 24. All right, so here's a problem. What is the standard form of an equation of an ellipse with a foci at 0 plus or minus root 17 and covertices at plus or minus 6, comma 0? Now, not necessary to solve this problem, but my brain cries out for a picture because it really likes to see what's going on. So my vertices are at plus or minus 6. And my foci is at 0, comma, plus or minus root 17. And unfortunately, I don't have the square root of 17 memorized, so let's find them really quick. 4.1. Alright, so I have a nice little picture of my ellipse. My major vertices are going to be here and here, and my minor ones are here and here. So let's use c squared equals a squared minus b squared. We know that our co-vertices is here, and if we look at our formula, the co-vertex is the b. Co-vertex 0, comma negative b and 0, comma b. So then moving forward on this problem, my b is going to be 6. We have, I'm going to replace, this is c, remember c is the foci. So I'm going to replace c with square root of 17. A squared is going to stay because I don't know what it is. And b squared we're going to replace with 6. Alright, so square root of 17 squared is 17. A squared is a squared, and 6 squared is 36. 36 to both sides. And a squared is equal to 53. So let's write the equation. So actually, I want to draw it just for fun. So let's find the square root of 53. 7.2. So my ellipse goes something like that. Y is my major axis because my focus is on it. So my A is going to go with my Y, and my B is going to go with the X. And that's how the picture helps me determine who's got the A and who's got the B. So now I'm just plugging in x squared equals, my B value is 6. And instead of putting square root of 53 and then squaring it, I'm just going to substitute a squared straight up here and put 53 in. So now, because I'm out of room, I'm going to replace this 6 squared with 36. And that's my answer.